In this video, we're going to be talking about how do we find the general solutions to differential equations. So when we solve differential equations, we're going to be learning how to find both general and particular solutions. This video will just be covering general solutions. And that means all of these answers will have plus c in them, okay, to represent that unknown constant that we have when we integrate. Implicit differentiation, which we've learned previously, and solving differential equations are essentially reverse processes. And the most important thing to remember when we are solving differential equations is to do a process called separating the variables. Basically, if an equation has x and y, making sure all of the x's are on one side of the equation and all of the y's are on the other. This is especially important in AP Calculus. Sometimes on the free response questions, they will not give you any credit on the question whatsoever if you do not separate the variables. So let's recall what we've learned previously, which is implicit differentiation. So we have seen questions like this that say find dy dx given x squared plus y squared equals 4. And we would take the derivative, and whenever we took the derivative of the y term, we would put dy dx, and then we would always solve for dy dx. So I would move the 2x over, and I'd solve and get dy dx equals negative x over y. Now let's talk about how do we reverse this. So if we are doing the reverse of implicit differentiation, we're essentially integrating and we're trying to figure out an original equation that would satisfy the differential equation. Now, with this being said, since we are only doing general solutions in this video, we cannot get an exact match. So if you notice over on the left here, we had equals 4. We will not be able to determine equals 4, but we could figure out that it is equal to some constant. All right, so this question says find the general solution to dy dx equals negative x over y. We have a proportion here. So first thing we're going to do is we're going to cross multiply. So that's going to give me y dy equals negative x dx. When I do that, I have successfully separated the variables. And then I'm going to integrate on both sides. So over on the left, I'm going to get y squared over 2. Over on the right, I'm going to get negative x squared over 2 plus c. All right, we want to see if we could get this to basically match what we were working with over here, just so that we can understand these as reverse processes. So I'm going to multiply everything by 2. Now, when I multiply c, some unknown constant, by 2, I'm still getting another unknown constant. So rather than writing 2c, I'm just going to keep it as c, because again, c and 2c, they're both constants. So I'm just going to write it in the simplified version of c. I'm going to now move the x squared to the other side. And you see that we get x squared plus y squared equals c. And this is what we call a general solution to that differential equation. Number 1, find the general solution to the differential equation dy dx equals 3 cosine 3x. I'm going to multiply both sides by dx to separate the variables. And then I'm going to integrate on both sides. Now, over on the left, this is like we have an imaginary 1 here, right? 1 times dy would still give me dy. So it's like that 1 is unwritten. But I'm going to use that to help me integrate. Over here, I'm going to get y. If we remember our integration over here, that 3 in front is really just a derivative of the inside. So I need to find the antiderivative of cosine, which is sine. We're going to keep that inner function the same, and we're going to put plus c. Okay. If we wanted to check any of these, we could just take the derivative and make sure it matches the original question. Number 2, find the general solution to the differential equation dy dx equals 2x. So again, I'm going to move the dx to the other side. You can think about it like multiplying both sides by dx, or if you put this over 1 and cross multiply, that's the same idea. We're going to integrate. Over here, I get y equals, this would give me 2x squared over 2, which is really just x squared plus c. Okay, let's take a look at some more. Number 3, when I cross multiply here, I do separate the variables. So now we're going to integrate. This looks like the demo problem from before where we already have a y on the left. So when we do this, it's almost like the reverse of power rule. We're going to add 1 to the exponent and divide by that number. Over here, this is 3x squared over 2 plus c. So for all of our general solutions, we're going to solve these in terms of y. So I'm going to multiply everything by 2. So recall earlier in the video, I mentioned that 2 times c is just some, again, unknown constant. So we're just going to leave it as c. We're going to take the square root, and we're going to put plus or minus in front of that radical to represent both possibilities. Okay, number 4, cross multiply or multiply both sides by dx, and you'll have your variables separated. Integrate both sides. Remember, it's like we have a 1 over here, so this gives me y. Now I know the derivative of tangent of x gives me secant squared x, so the antiderivative of secant squared is tangent x, and we're going to put plus c at the end. All right, we're going to take a look now at some that are a little bit more advanced. So if we look at number 5, find the general solution, and we have the equation dy dx equals x times y. All right, so if I multiply both sides by dx, like we've been doing so far in this video, it doesn't get rid of, or it gets rid of the fraction, but it doesn't separate the variables successfully. So what I'm going to have to do is divide by y on both sides. The way that I'm going to write that is as if I'm multiplying both sides by 1 over y, right? Dividing by y or multiplying by 1 over y would be the same thing. And now I am able to integrate because I have separated my variables. So think about it as step 1 to any differential equation problem is to separate the variables. Once you've done that, step 2 would be to actually integrate. All right, so this is going to give me the ln of the absolute value of y equals x squared over 2 plus c. And remember, we want to get y by itself here. So what I'm going to do is I'm going to treat e as the base on both sides of the equation, and I'm going to make that original equation essentially become the exponent. So it's going to be e to the power of ln of y, over on the right, e to the power of x squared over 2 plus c. When we do that, we are going to get y equals e to the x squared over 2 plus c. And if we know our log rules, we could rewrite that right-hand side a few different ways. So this is really y equals e to the x squared over 2 times e to the c. And if we think about this, this piece over here is just, again, some other constant. So I'm going to bring that to the front. So my answer would be y equals c e to the x squared over 2. Okay, so again, we still have a c, that unknown constant in this problem. It's just when we rewrite it using our log and exponential rules, it basically moves to the front. So let's practice another one that looks like that so we can get the hang of it. dy dx equals e to the xy. So again, multiply, the steps will get repetitive a bit. Multiply both sides by dx. That did not successfully separate the variables, so I'm going to multiply by 1 over y. And now I can integrate once those variables are separated. So I get ln of absolute value of y equals e to the x plus c. It's like I'm going to make e the base on both sides, and that's my new exponent. Over here, everything will cancel out, and I'm just left with y. Over here, I'm left with e, and then in the exponent, e to the x plus c. Now, we talked about in the previous problem how we could rewrite that right side as e to the x times e to the c. But now that I'm getting used to this idea that this is going to happen in these problems, I'm just going to know to, okay, let's bump that c to the front, and I have c times e to the x power. All right, on number 7, we're going to repeat the same process. We are going to multiply by dx on both sides, but that will not separate the variables. So I'm going to be moving the y over to the left. Then I will integrate. Since we want to get y by itself, we are going to put e as the base on each side. And all of this, just like we've seen in questions 5 and 6, allows us to rewrite this as y equals c times e to the 4x cubed over 3. All right, one last question here for number 8. Cross multiply. This successfully separates the variables, so I know I'm not going to have the natural log and e throughout the work of this question. So now I can integrate. And we want to get y by itself. So I'm going to start by multiplying everything by 2. Then I'm going to divide everything by 5. Sorry, let's put a 4 back in here. And then we're going to take the square root of both sides, which will give us y equals plus or minus the square root of 4 over 5x squared plus 6 over 5x plus c. In the next video, we're going to be talking about how do we find the particular solution for a given differential equation.